Chapter 4. Chapter 4 is now about motion in more than one dimension, in multiple dimensions. So it's kinematics about 2 and 3 dimensions. And the main objective is that we will learn about how to solve problems about motion in a plane, basically 2 dimensions. Although 3 dimensions, it can easily be generalized to 3 dimensions, but the focus will be 2 dimensions. And let's talk about the details. So by the end of this chapter, you will be able to calculate the position vectors in multi-dimensional displacement problems. Okay? Solve for the displacement in 2 or 3 dimensions. Again, the focus is 2 dimensions, but sometimes we'll talk about 3 dimensions. Calculate the velocity vector given the position vector as a function of time. And then calculate the average velocity in multiple dimensions. So, right, we had the instantaneous velocity and the average velocity. So how do we calculate the average velocity when we are in more than one dimension? That's one of the things that we will learn. Calculate the acceleration vector given the velocity function in unit vector notation. So given the velocity function in unit vector notation. So we learned about vectors in the last chapter. So let me write here. So let's say I have a velocity vector as, let's say, as a function of time, 2 t cubed I hat plus 4t j hat plus, let's say, 2 t to the, well, let's get to the 7th power, k hat. All right. So here's the velocity as a function of time. What is the acceleration? How do we calculate the acceleration of the particle? Okay. So we will use calculus, as you may guess, to do this. Okay. You may have seen this in Calc 3 already if you took Calc 3. If you haven't, it's not a prerequisite, but we will learn it. So, and then we will describe the motion of a particle with constant acceleration in 2 or 3 dimensions. The main focus will be in 2 dimensions. So let's say I throw something and it's moving like this. So it goes up and to the right and it's going down. That's 2 dimensions. So it's moving along the y direction and also along the x direction. So how do we describe this motion? Okay, using vectors. So we'll do that. And then we'll see that the problem in 2 dimensions separates into 2 one-dimensional problems connected by time. So that's this. And then we will express the acceleration also in unit vector notation. So again, that's just basically chapter 3 again. And we will use the, again, one-dimensional motion in perpendicular directions to analyze projectile motion. So again, projectile motion is really there is acceleration in the y direction and there is no acceleration in the x direction, and so it separates nicely like that. I'll discuss that in the coming videos. And for a projectile, we need to be able to calculate the range of the projectile, the time of flight, the maximum height of a projectile that is launched and impacts a flat horizontal surface. Find the time of flight and the impact velocity for a projectile that lands at a different height from the original launching point. Calculate the trajectory of a projectile, meaning what's the position of a projectile as a function of time? At any time, where is the location of the projectile? Solve for the centripetal acceleration of an object moving in a circular path. So we'll talk about projectile motion, motion under gravity, and then we will talk also, a second focus will be circular motion. Okay? And circular motion is here to stay also, and we will be stuck with it for the rest of the semester. We'll talk about circular motion all the time. Use the equations of circular motion to find position, velocity, and acceleration of a particle in circular motion. Explain the differences between centripetal acceleration and tangential acceleration resulting from non-uniform circular motion. Again, more details about that. Evaluate centripetal and tangential acceleration of non-uniform circular motion and find the total acceleration vector. So acceleration will be a vector and it will have two components. One of them will be tangential and one of them will be toward the center for circular motion. And then explain the concept of inertial frames, of reference frames, and write the position and velocity vector equations for relative motion. And so we'll talk about relative motion. So let's say you're standing here and somebody is on a train and the train is moving to your right and then the person is within the train and the person is maybe walking or jumping in the train. So how does the person look like to you and how does the person look like to somebody standing on the train with them? Okay, so that would be relative motion. And then we'll talk about one-dimensional and two-dimensional relative motion problems using the position and velocity vector quantities. Again, once we understand vectors, all of these concepts will be easy. And that's it for chapter 4.